The second part of the experiment of a FPGA-based adaptive sleep posture analysis accelerator for real-time monitoring. If we observe exactly at this part, fine, we are having of a again the same flow, means a flow chart which we have mentioned just now. Right now, we in this case when we are having of a, our sensors, PI are going to identify. Here we are going to keep a PI sensor and find out whether the human is available on a bed or not. Once it is a confined from the PI sensor, ultrasonic sensors are going to enable through the FPGA device. So once it is enabled, the sensors are going to capture of a data and going to store, means the array of signals are represented using of a sensor fusion. Once it is a confined that, yes, it was the learning process. After the once the learning process completed, the level 2 was regarding of a posture evaluation stage. Now we are at the posture evaluation stage. At the posture evaluation stage, what was the position of the current pose and what was the past pose? So the both the positions were the data was captured here, and the time taken of the pose current and retrieving towards a passport or past positions to the current position. So when both the postures are common, so when it is in a common posture, so it confines that no change in the posture. So by that we says that yes, the posture was a generic way or a static posture. This was one of the aspect while calculating of the sleep posture. One of the major challenge in a sleep posture analysis was analyzing of a adaptive. Means the human cannot be in a long time in a same posture, so that we came out with the adaptive analysis of the sleep postures. So how much time taken to calculate from one posture to other posture? How much it takes? So where exactly it is going to useful? When human was facing with the ulcer issues or any breathing issues, all these scenarios required over the time and duration from one posture to other posture, the human is varying from that. So in this regard, the proposed hardware schemes are going to provide that solutions to that, the timing between one posture to other posture by the using of accelerator. So this was we are calling as a counter. Once it's a confined, it's a adaptive. So it goes to calculate the adaptive time period. Among that adaptive time period, it is going to register in a FIFO. Among the FIFO, your present posture and current pose and a past pose. They are going to have the comparison between these two and fed back towards that one towards the ABC, sorry, HBC. That was we are calling as a hierarchical binary classifier. Once it moves towards a hierarchical binary classifier, it confines us, yes, the human was in this posture from the initial stage and this was the current pose. So that information we are going to retrieve by this mechanism. So this was the FPGA which we prefer to use. So here we are saying that the adaptive sleep posture. Here we are represented of two things are there. One was your PPP, means a past pose, and CP was the current pose which the human was there. This was a power consumption. The advantage of the hardware schemes using of FPGAs was over the other methods is the first point, it consumes a very less power comparatively with the other system. Yes, the computational part is consuming around of a 1.2 watts of power while computing of the algorithm. We look into our experimental challenge. Yes, in this case, the human was very initially, it was the left side, means facing towards the right side. He is in a position. Yes, comes to this part. We are saying that yes, the human was changing of his posture, and then he was started off with changing of his postures one by one, and then yes, now let me see the what was the hardware was changing. Yes, please look into the hardware. Yes, the hardware was showing that. Yes, we go back towards the hardware, and in a hardware it was shown right here. The thing is, yes, what was your posture? How much time taken to it? So these are the timings are also mentioned in this case as around of a 9.64 seconds. It was taken a time period for us from these postures to next posture. Yes. In this process, the human was varying his postures continuously in all the 8 postures which we are defined over from the in the proposed method. Means here we are having of a two major. One was the forward supine model, the other one is a reverse supine model, and other one where we are having of a left lateral posture and a right lateral posture, and also we are having of a left fetus model and a left end model and right end model and a right footing model. So all these 8 models, right? The human was changing of his postures. From these models, let we know exactly the how much time taken by individual from his past postures to present posture. So if you observe, it's 11 seconds. So among these 11 seconds, human was a change his posture. This same information was driven out towards the at the point of the towards the either the required people like a attendance or a hospital people or any other analysis purpose, we can capture of this data and we can calculate it and confine what type of a challenge. Yes, this is a having of the novelty among this total process. One novelty is the adaptive. Till date the adaptive mechanism is not mentioned by any sleep posture researchers. That was a one point. Second point, we are providing hardware solutions for this by using of FPGA. Obviously, FPGA consumes a very less power among others, right? Yes. Thank you.